Okay, so we're looking at horizontal asymptotes. So we have three questions here. We'll start with the first one. We're going to evaluate the limit as x approaches infinity, which will help us discover if there is a horizontal asymptote or not. So as our x value goes ever greater, is there any value that's stopping it, okay, from reaching anywhere? So on our first question here, the first step we want to do is we actually want to equate, I'll write it out again, limit of x as it approaches positive infinity. We want to make equal equations, but so that every number is to the highest degree of the largest variable. So what does that mean? And what we're talking about here as a side note, so let's say I had 3x cubed plus 2x squared plus x. What I want to do is I want to take the variable with the highest exponent, which in this case is our x to the power of 3, and I want to divide or common factor out x cubed from each of these. Okay. So when we do that, our x cubed comes to the outside, and the values we have inside are 3. Here we'll have 2 over x, and here we'll have 1 over x squared when we factor that out. Okay. So we want to set up equivalents like this so that we have a common factor on the outside. So I'm going to do that for both the top and the bottom separately. Now the highest variable in the top is the value of x, so we're going to common factor x out. So the limit as x approaches positive infinity. When I common factor x out, we have x over 2, or sorry, x times 2 minus 3 over x. Okay? And on the bottom, same idea, we're going to common factor out our value of x. When we factor out x, we have 1 plus 1 over x. So now we're dealing with equations that look a little different. And the reason we're going to do that is because now we're going to be able to plug in the value of x approaches infinity to our x values. Okay? So in each of these values, we're going to be multiplying. Now, in this case, I have an x on both outsides, so I'm going to simplify this equation and just leave what we have on top. We'll get rid of both the x values. We have 2 minus 3 over x divided by 1 plus 1 over x. Okay. And we're going to plug our limit into these equations. So limit. When we plug our limit in, this will now become infinity. I'll plug those values in. We'll get 2 minus 3 over an infinite value divided by 1 plus 1 over another infinite value. Okay? And what's important here is that 3 divided by an infinite value, this is an extremely large number. And the larger we make a denominator, the smaller a number gets. In fact, this is so large that it essentially makes this number the value of 0. It'll be so small that it would be rounded if we were to use it in realistic terms. The value is essentially 0. So it turns this value into 0, as does this one. No matter how high this number is on top, infinity is so infinitely large. It's so much larger than that number that it is essentially equating to 0. So this becomes 0, and this becomes 0, which then leaves us with 2 minus 0 over 1 plus 0, which leaves us with what? 2. So our horizontal asymptote is at a value of x is equal to 2. So if we were to sketch this, okay, sorry, not x equals to 2, and y is equal to 2. So at our y value of 2, we have some horizontal asymptote here. Okay? Now, we could have solved this very quickly. There's a trick. If the variables, or the highest degree of both the top and bottom variable are the same, just like they are here, we really only have to focus on the coefficients in front of them. The coefficient here is 2. Coefficient here is 1. What is 2 divided by 1? 2. So our horizontal asymptote is 2. It's a really easy way to look at it. Okay? We'll do this one with the limit, and then we'll show you the trick to it after. Let me just add a new page quickly. It was x over x squared plus 1. So x over x squared plus 1. And this limit was as x approached negative infinity. Correct? So, same idea. We want to divide or common factor out our values. So on the top, it would just leave me with x times 1, so we'll just leave it as x on top. There's nothing to common factor. Out here, we can common factor out x squared, which will leave us with 1 plus 1 over x squared. Okay? Of our limit as x approaches negative infinity. So we common factored out the variable to the highest degree on both the numerator and denominator. Now we're going to plug in our value of negative infinity. Okay? So here, our x value becomes negative infinity on top. Okay. Oh, sorry. Before I do that, forgot to do this part. We can also now simplify this equation. Because this is this x and this is x squared, this x will turn into the value of 1, and this will be just the value of x, which is very important. 1 over x times 1 plus 1 over x squared. So now that we've simplified, we always must simplify first, we can plug in x to negative infinity. Okay? And x to negative infinity here is going to become 1 over infinity times 1 plus this value here becomes infinity also, and 1 divided by infinity is 0. So we have infinity times 1, which is still infinity. Think of infinity like gobbling up any number, similar to what 0 does. And 1 over infinity. Well, we've talked about 1 over infinity is essentially what number? 0. So our horizontal asymptote is at y equals 0. So the x-axis is where our horizontal asymptote is. Now, the trick to this idea here is when our denominator's variable is larger, the exponent, than the top one, we're going to get a horizontal asymptote of 0 in these cases. Okay? So whenever the variable on the bottom has a larger exponent, what will end up happening is once we cancel out, assuming there is a horizontal asymptote, we'll end up with a value of 0 because we'll always have infinity on the bottom of whatever number is on top, which essentially equates to 0. Okay? So instead of doing this the limit way, so we've done 1 and 2, what are the highest degrees of variables here? X to the power of 2. Okay? Are they the same? Yep. So the highest one is both the same in both. What are the coefficients? 2 over 3, so 2 and 3. So what's the horizontal asymptote? 2 over 3. We just have to look at those two. Had I given you the same question like this, what would the horizontal asymptote be here? 0. Why is it 0? Because our variable's exponent on the bottom is larger, which essentially means we're going to be left with infinity on the bottom, so our horizontal asymptote is 0. So for this one, it's 3 over 2, and for this one, it is 0. Okay?